Welcome to today's lecture. This is Blessed Elvis. So in today's lesson, we are going to discuss logarithm functions. Logarithm functions are simply the inverse of exponential functions. So before we go deeper, let's understand how we can convert from exponential functions into logarithm functions. So let's say, for example, you have an exponential function which is y equals to a raised to power x. So expressing this into logarithm form, there are simple rules that we should understand. So here, to express this as logarithm form, the value here becomes the base. So we have the log here, so this value here becomes the base. So we're going to have a down there. And then this value which is here, that is y, is going to come here, where we have this. And the power becomes the what? The value of the equal sign, which is here. So this is how we basically convert from exponential function into logarithm functions. Let's look at more examples. Let's say we have 8 equals to 2 raised to power 3. So how can this be written in logarithm forms? So in this case, then we're going to have log, the value which is here is going to be our base, okay, and then the value that is on the equal sign is going to be here. So this is equal to, then the power becomes the what? The value of the equal sign. So this is how this is going to be. So let's look at one last example, how we can convert from exponential function to logarithm function. We know this is the same as 10 raised to power 2. So how can we write this into logarithm form? So in this case, this is going to be our base, and this is going to be our value of the log. So let's say we have log, so here this is going to be 10, and then this one here is going to be here, and then the power becomes the value of the equal sign. So this is basically the rule behind converting from exponential function into logarithm functions. Now let's look at how we can convert from logs into exponential functions. We have to know both ways. So conversely, let's say we have x, let's say here we have x, and then here we have 10 equals to 4. So what do you think this is going to be in rather exponential form? So according to exponential form, this is going to be here on the equal sign, and then we're going to have this one is going to be x, and if you remember, the one that was on the equal sign was basically the power. So this is how we convert into exponential functions. Now let's say we also have, let's look at another example. Let's say we have log 3, then we have x here equals to 5. How can this be written in exponential form? So writing this in exponential form, we know that this is going to be x, and then this will be equal to, then this one here will be here, and then this one is going to be our power. So we're going to have this, that's 5. So we're going to have that. So this is basically the rule behind converting from exponential function to logarithm function, and from logarithm function into exponential function. Now that we have understood that, let's look at a few examples on how we can solve the values of x. Let's say we have x equals to log, let's say log 2 64. So how can we solve the value of x for this? So the first step to go about this is first converting this into exponential function. So we know that converting this into exponential function, by now this is the same as this one. Now it's going to be 2, and then this is going to be power x equals to what? Equals to this, that is 64. Now that we have converted, we can now simply solve this expression here. We know this is the same as 2 raised to power x equals to 64 is what? Is 2 to the 6th power. So that is this. So this and that cancels since they have the same base, and then we have x equals to x, these powers here. So this is the value of x. Let's look at another example. Let's say we have log, let's say x, and then here we have 25 equals to 2. How can we solve this one? So here we know that this is going to be x, and then this one is going to be the power of x, okay, and then this one is going to come on the equal sign. So we have that. Okay, so how can we solve such an inverse function? So here we have x squared equals to this one here is the same as 5 to the second power. So since we have the same powers, we can simply cancel them. So whenever you have the same powers or the same bases, you cancel them out, and then what remains is your answer. So in this case, x equals to 5 is our answer. So let's look at another example. Let's say we have x equals to log, let's say 3, and then we have 1 over 3. So how can we write this one? So always remember, the first step is converting this into exponential function. So this is the same as 3 raised to power x is going to equal to 1 over 3. So I'm sure by now you have understood how we can convert them into exponential functions. So in this case, this is the same as x3 rather, x equals to, this is the same as 3 power negative 1. So we have the same bases, so we can cancel them, and then we remain with x equals to negative 1. So this is the value of x. Let's look at another one last example. Let's say we have log 3, and then we have x equals to 4. How can we convert this into the exponential function? So this is the same as 3 raised to power 4 equals to x, and we know 3 raised to power 4 is h1, so this is h1 equals to x. So in this case then, x is equal to h1. So this is the value of x. So this is actually the rule behind how we can convert from exponential function to logarithm function, from logarithm function to exponential function, and solving them. So if you have been given such kind of questions like this one, you first have to convert them into exponential function and then solve the given expression. That's how we do it. So let's look at one of the few, or rather few, rules that we follow whenever we are answering some of the questions. So let's say some of the rules we have. If you have, by now we know that if you have an exponential function, let's say in form of p equals to a power m, this now into logarithm function is the same as m equals to log a power p. By now we know that this is how this comes about whenever we convert from exponential function into logarithm function. If we have, let's say again, q equals to a power n, you can even pause the video and try this one. How is this going to be in logarithm function? Okay, so this is going to be n equals to log a and then q. So these are the rules behind. Now let's look at product rule, or rather multiplication rule. If we have log, make sure that you know these rules. Let's say if these are two values. If we are multiplying two values and then we have log here, this is the same as log a of p plus log a of q. This is how we convert from the product to addition. So always whenever you have the product of two logs, you simply add the two logs. When you have the division of two logs, let me just first give an example before we go into division. So let's say we have log a and then we are multiplying four numbers. So what this simply means is that we're going to have log of a 4 added to log of a 3. So this is how we convert. Okay, let's now look at division rule. Let's say you are dividing the values of, let's say, p over q. So this is the same as log. So whenever you are dividing, you always subtract. Whenever you are multiplying, you always add. So this is how this goes about. Let's look at an example. Let's say you have log of a, let's say 12 divided by 4. So writing this into this form, this is the same as log of a 12 minus log a 4. So this is basically how we convert them. Okay, so apart from that, let's also look at power rule. When you have log of a p raised to power, this power always comes in front of the log. So in this case, it's going to be n log a of p. So this is how we do it. So whenever you have the power on the log of the base, you always write the power in front of the log. So let's look at an example. Let's say we have log a power 2 power 3. So writing this into log form, this 3 here is going to come in front, and we're going to have log, or rather 3 log a 2. This is how we convert. Let's look at one last example. Let's say we have log a and then root of 3. By now, we know that a root is the same as the power of half of the given base. So in this case, it's going to be power of half power of 3. Okay. Then in this case, then this power half is going to come in front according to what we are from doing. And then we're going to have log 3 there. This is how we convert them. So hopefully you have gotten some concepts. However, there are two special logs that we go. There are two rules that we call special logs, or rather special logarithm functions. When you have the same values, let's say base a and a, where a and a are values, when you have these same values here, this sorry for the disturbance, this is always equal to 1. Whenever you have the same values here, it's the same as this log is 1. Let's say you have log 2 and 2 here. Whenever you have manipulated your logarithm function and then it gives you the same values here, this is always 1. The whole of this is 1. Even if you have log 100 and then here you have 100, this is 1. Okay? So make sure that you get that, you understand this. Now, if you have two different logs, let's say you have log 1 there, this is always equal to 0, because converting this into exponential function, this is the same as a power 0 equals to 1, and n value raised to power 0 is 1. So that's why this is always equal to 0. So whenever you have different values here, you always equate to 0. Okay, let's look at some of the examples. Let's say we have log 7 here, and this is equals to 49. So this, let's simplify this. So we know that this is log of 7, and then 49 is the same as 7 raised to power 2. Okay, and by the rule, the power will always come to the front. So we're going to have 7 and 7 there. And what you are from doing, whenever you have the same values here, you always equate to 1. So this is the same as we have 1. So in this case, 1 multiplied by 2, it's what? It's 2. So this is the answer. Let's look at one last example. Let's say we have log 3, and then here we have 1, 1, and 9. So this is the same as log. According to division rule, you always subtract whenever you are dividing. So we are going to have log 3 and 9 there. So in this case, since these are different values, it means we have what? 0 equals to, or rather minus. Here we have 9. Let's simplify that. So it's the same as 3 here. Now 9 is the same as 3 raised to power 2. So we're going to have 3, rather 0. This power is going to come to the front. So we're going to have 3 and 3 there. So we are going to have 0 minus 2. Whenever we have the same values here, by the rule, we always have 1. So in this case, let me just write it here, hopefully. Okay, let me just wrap this for the sake of space. So let me just remove whatever we have already done on top there. So here we're gonna have 0 minus 2, 1, and then 0, 2 multiplied by 1, it's 2, and then 0 subtract 2, it's what? It's negative 2. So this is the answer. This marks the end of our part 1 for logarithm functions. Thanks once again guys for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.